Okay, the average value of f over the interval from a to b. Again, the mechanics of this are extraordinarily simple. I take the integral from a to b and divide by the difference from b to a. This is division. Multiplying by a fraction is the same as division. So, all you have to learn is how to speak the words that are conveyed in this, what it really means. The average value of the function. So what is the function? Doesn't matter. I give you a function. It's changing. It's a parabola. It's not staying the same. From -1 to 2, there's going to be some change, and this part of the function would give me the total net change from A to B over a distance of 3. So if I know how much it's changed, and I know that it changed over 3 units of time, then on average, or 3 units, that's how much changed per unit. Let's go back a little bit to what I was talking about earlier. Let's say you're going to Jacksonville, and if your speedometer always says 60 miles an hour, and you're going from Gainesville, outside of Gainesville to the outside of Jacksonville is approximately 60 miles. So if I look at my speedometer and I'm always going exactly 60 miles an hour for 1 hour, then on average I've traveled 60 miles per hour. Very simple. However, you have Waldo, you have Stark, you have Lottie in between. So the reality is your speedometer is going to be going up and down. Sometimes you're stopped at a stoplight, then you're accelerating, and you're going much. So that speedometer is your rate of change, how fast you're moving. So as that speedometer is going from Gainesville, outside of Gainesville to outside of Jacksonville, it may take you an hour, but you were never or hardly ever really traveling 60 miles per hour. So your speed can be very, very different. And if I graph it and look at it, again, imagine I'm outside of Gainesville at a stop sign. I start. My speed is 0. And then I start accelerating. I get faster and faster and faster. Maybe I get up to 65, 70 miles an hour. Then I come into Waldo and I slow down. And I go through Waldo, then I speed up. So my speed is always changing. So when I accumulate my distance from the time I left Gainesville to the time I get to Jacksonville, I've accumulated 60 miles in 1 hour, which means my average speed is 60 miles per hour. That's what this calculates. Looks a little bit intimidating mathematically, very look of intimidation, but the reality is very straightforward. Okay, so I'm changing parabola, and I can accumulate that change, and that total accumulation of change is right there. That's how much I've accumulated. Once you add and subtract that all together and divide by 3, same as multiplying by 1/3, because from -1 to 2 is a total net change of 3. 2 minus -1 is 3. So my total change divided by how long it took me to make that change is my average rate of change. Let's make this in something that actually makes sense, like a word problem. So this is my temperature. Temperature is changing. It gets warm, it gets cold. So it's constantly changing from 8 a.m. to 6 p.m. Okay? Now, one thing they did is they made it a 24-hour clock. So 6 p.m. is 6 hours after 12. 12 plus 6 is 18. So after the 8th hour of the day through the 18th hour, I can find what the average temperature was. So this is the temperature at any given time. I look at this, and this wouldn't really make sense to think about how much temperature I accumulated, and that doesn't really matter because you're not really accumulating temperature. So that's why this makes a lot more sense to talk about the average temperature. So I look at this, and again, temperature at any given time, take the antiderivative and integrate it from 8 to 18, which is a 10-hour interval. 10-hour interval. So this is my average temperature was 78.4 degrees if I was to add all of these temperatures together for every hour, I would get this big number here, which without calculating it directly is 1780 something, which would be the temperature all accumulated over those 10 hours, if you could do such a thing, divided by 10, that's it. So mechanics, take the antiderivative and evaluate it from 8 to 18, plug in 18 into here, 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 and you get this number. Plug in 8 into here, 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 you get this number. Okay, mechanics, nothing new. All it is in learning to interpret what it is. The net accumulation divided by 10 gives me an average. That's it. So, let's look at the next. Oh, I only give a couple examples on this one. Oh, that was the last of this section. So, only 2 examples, but again, it never changes. It's just, let's actually look at maybe a question. Okay. So let's look at these word problems, and all I'm going to do right now is set up whether I want to take the first formula or the second formula. And I'm going to actually, I'm just going to look at these ones to the side here. Okay. So here's the question. Forget everything up here. Let's just look at the question, and this determines our setup. Find the amount of water that flows from the tank. So I'm looking for a total amount of accumulation. That means I'm going to take the antiderivative from 0 to 10 of this. How much did the bacteria population increase during the first 2 hours? Okay, I'm looking for a total accumulation antiderivative from 0 to 2 of this. Simple as that. I go down. This one, these can get confusing because I don't know whether I'm talking about the average rate of change immediately or not. How much electricity was consumed during that day? Consumed, so this is a total accumulation. So antiderivative from here to accumulate from 0 to 24 of this. It's all about the setup. And let's go to the next set of questions. Oh, keyword, average balance. So this is different. This is not how much total did I accumulate, but what is the average. So here's my balance. So during the first 5 years, so I'm going to take the antiderivative, which looks like an accumulation from 0 to 5. So that looks just like the total net change. However, after I go from 0 to 5 accumulation with the antiderivative, I'm then just going to divide that value by 5 because this is an average balance, which tells me to use the average rate of change. So the only difference between an accumulation and an average in this section is accumulation, I'm taking the antiderivative from beginning to end, and an average, I'm taking the antiderivative from beginning to end and dividing it by that amount. That's all. So basically the formulas are identical. One requires a division, and you know to divide when it says average. I hope this cleared everything up for this section.